Alright, so we've started recording, and let me take you to practice quiz. Problem 1. Just do problem number 1. So, reduce that, come up with a reduced answer 2 different ways. Thirty seconds more. Alright, so 3 squared over 3 to the 5th. Here's one way to do it. Five 3's in the bottom, 2 of them on the top. Divide by 3 and you get 1. And then multiply together and you get 1 over 27. Okay. Another way to do it. You could say this is 2 minus 5. Because subtract. When you're dividing, you subtract the exponents. And a negative exponent means this. We still are going to get the same thing. Yet another way. If I took this as my starting one and subtracted in this direction, I'd still get the same answer. And give me a little feedback on number 1, please. Alright, let's go back. Do number 2. Actually, let me change something. I want to change this to this. Okay. Do that one now. 30 seconds more. Alright, the first parenthesis doesn't do anything. I can just drop it. But in order to drop the second parenthesis, I have to distribute both the negative and the 2. And they're double negative making positive right here. And then these two are like terms. Oops. It's negative x. And these two are like terms. Plus 7. And then do number 3. Excuse me. Thirty seconds more. Alright, 2x minus 3 times 2x minus 3. It's got to be written like that. My temptation is to want to go 4x squared minus 9. But that can't distribute that exponent when there's more than one term. There's 2 terms inside the parentheses. I have to do it like this. Distribute out. Now I'm going to do this little shortcut method. Now I can do it all in my head. 4x squared minus 6x minus 6x is minus 12x plus 9. So you can see if I had just distributed that minus, I'd have a very different answer. Okay, a little feedback on numbers 2 and 3. Okay, and do number 4. 30 seconds more. Alright, so I'm going to make some observations first. There are two variables in one equation. That means you're going to have an infinite number of solutions. Okay, and then if each solution is represented by a dot, now how do you represent a solution by a dot? Like, for instance, if you get a point, like if x is 1 and y is -4, then the point 1, -4, we put a dot there on our graph. Each solution is represented by a dot. The dots line up in a straight line. So the straight line is thought of as a whole bunch of dots lining up. Every one of those dots is a solution of that equation. And then the quick way, so we looked at some quick ways to get to the graphing that very quickly. One such way is the intercepts method. Another way would be just pick, a couple random points. Doesn't really matter what you pick, and just kind of fill them in. Doesn't matter which method you use, you need at least 2 points to be able to graph to the line. And then you could pick a third point to check, because if it doesn't line up on the line, that's a good check. Alright, so if we pick x being 0, now we do this thing, we cover up the x term when x is 0, and we look at it and we can immediately tell y has to be -6. We cover up the y, and we look at the equation and we say, oh, the x has got to be 3. Now similarly, we could have plugged them in. When x is 1, you would have just gotten 2 minus y equals 6. And then y turns out to be not 4, it had to be -4. And then for this one, if you plug in 2 for the x, you get the equation 4 minus what number is 6. It's not 2, but -2 in here. Okay. So here I'm showing a couple different ways. And then to graph it, (0, -6), 3, 0, 1, -4, 2, -2. Okay. So now I can say 0, -6, if I was doing it this really quick way, and 3, 0, and say these two and connect them. But I can also show that 1, -4, that really looks like it would line up on the same line. And 2, -2, yep, that'll sure line up on that same line. And then we just connect them all together. This is an infinite number of points. Each point is a solution to this equation. Give me a little feedback on number 4. Okay. What's true about every x-intercept? What's true about every y-intercept? Thirty seconds more. Right. What's true about every x-intercept is that the y-coordinate is 0. Now I can demonstrate that. Let's look back over here. Which one of these 2 points was the x-intercept? Well, here's the x-axis. This one was the x-intercept, and that was 3, 0, and its y-coordinate was 0. Because the y is the height, and you can't move up or down from the x-axis. So that's the case there. And what's true about every y-intercept? The x is 0. And we see that up here. When x was 0, y is -6. The x is how much you move away from the y-axis by moving left or right. And you don't move any away, so you're stuck on the y-axis. Alright. Brief bit of feedback on number 5. Number 6, 519 out of 879 people were wearing masks at the Santa Fe Plaza. What percentage were wearing masks? Thirty seconds more. Okay, this problem reviews all 3 different formats that we covered. Fractions. And in the history of math, my guess is that fractions came first, before decimals or percentages. Because they're kind of intuitive, they're kind of natural. This, oh, I forgot the word out of. Okay, now this fraction, you just punch it into your calculator, and it tells you 0.59 and some other things, but we'll just call it 0.59. And that's converting fraction to decimal. The calculator does it for you. And then we convert that to percentage by moving the decimal 2 places to the right, inserting percent sign. 59%, more than half of the people were wearing masks. Give me a little feedback on number 6, please. So it really can vary widely on whether the review is needed or not, depending on the person, but this recall practice will strengthen those connections in your brain. All right, let's go to number 7. Do those 3. "30 seconds more. All right, the first one. You have 2 negatives making a positive. The second one, the negative only applies to the nearest thing. This is the same as this. So one answer is positive, the other is negative. On this one, the 2 negative signs do not interact with each other. They don't cancel each other out, because up in the exponent is very different than that other one. So anything to a negative exponent, we bring it to the bottom. And change the -2 to +2. And that becomes -4 times -4, which is +16. 1/16. Okay, a little feedback on number 7. All right, so now we're going to change gears. I'm going to have you go to Canvas for our class, click on discussions like we did last week, and there's a new discussion you'll find, needed feedback. So I'm going to give you a moment to get there. And ask you to please write about the use of OneNote. Was it helpful? If it was helpful, how so? To ease the burden of taking notes, did you refer to these notes outside of class? Did you open up OneNote prior to class so you could control what was displayed in OneNote? Or was it something you hardly used at all? Just honest feedback would be much appreciated. So if you can hit the reply button at the bottom, and let me give you about 3 minutes for this. So at about 1 o'clock, I'll resume. Jane, if you can finish up in the next minute.
I have trouble finding that in Canvas. I
It's
cannot
not
open
there?
it.
Oh.
I try to open it, but nothing is coming up. I don't know if it's me.
Me.
Try refreshing Canvas.
Okay. Amelia, try refreshing, see if that works. Let me go into my student view.
If not, I'll direct you to get to there if you're having trouble with it.
Okay, yeah, some of the others. Got it. And Amelia, you can do that. You can't do it now. You can do it right after class. Okay. All right, let us resume. And questions now.
I have questions about the, I'm not sure if we've gotten to there yet. I might have done it a bit early, but homework 3.3.
Yes.
And it's for number 30 and 42, 40, and 50.
All right, let's start with number 30.
Okay?
All right. So 3.3 number 30. Y equals 1/2 x. And the directions say for each of the following lines, the x-intercept and y-intercept are both 0, which means that the graph will go through the origin, 0, 0. Graph each line by finding a point on each other than the origin and then drawing the line through that point and the origin. So what they're talking about there is that if you try to graph using the intercepts method, and then you cover up the x, and then you cover up the y, in both cases you wind up getting 0. And you just repeat the same point twice. So the only way you can really graph this is you got to come up with another point. So we can pick anything you want. We'll pick it for x. When x is 4, this is like a recipe. It tells you, this is how you get the y. Take the x, multiply it by 1/2, and then you get 2. And now I can graph it. I have 2 separate points. 0, 0, and 1, 2, 3, 4, 1, 2. So those 2 points, 0, 0, and 4, 2, I connect them together. Right. Yes.
That's still a bit confusing to me. I thought you would graph 4 and 2.
What do you mean?
Well, what I mean is, instead of, because you're starting at the origin, then you go all the way up to the 4th point instead of 2 to the 4th point. That's confused me a lot.
Okay.
Sorry, I'm not explaining it correctly. It's confusing.
All right. Let me ask you, do you have an impulse to put an x here?
Yes.
And then put an x here?
Yes.
Okay. That is a very common reaction among lots of students, so you're not alone in that at all. Instead of putting 2 separate marks, this is 1 point. And you kind of think of it's directions. As, to get to my house from downtown, you have to go 4 blocks east. And then you go 2 blocks north. And there's my house. And don't put an X on either of these spots, just the final X on your final destination.
Oh, okay.
Okay?
Now it's coming to me. It's coming to me now.
Okay. Very good.
Okay, it's coming to me now.
And we always go left or right first, and then up or down second. And that's another confusing thing. Some people say, 4, 2, they'll go 4 up and then 2 over. But it's always got to be horizontal first and then vertical.
Okay. Thank you on that one.
You're welcome.
Could you help me on the other?
Give me another one,
no.
one at a time.
Okay. 42.
42.
Yes.
I have a question about that last one that you just graphed really
Yeah.
quickly.
Mm-hmm.
You said you put an X on your final destination
Yeah.
and not, is that because there's only one solution? Or
Okay. It's just there's an infinite number of solutions. So for instance, if this was a 2, the X was a 2, plug it in there and you'd get a 1. If the X was a 6, you get a 3. But each one of these is really a point in space. Freddie, I'm going to need you to mute your mic. We're getting extra noise.
Oops. Sorry about that.
No problem.
My apologies.
Okay. So it's going to be like this one, 2 to the right and 1 up. Be that point. And 6 to the right, 3 up would be like over here. And so on. Still an infinite number of points, but each one of these is only one mark. 2 coordinates to make one mark. Does that answer your question?
yeah, thank you.
You're welcome. All right, let's go to 42. Okay, so it says graph the line that passes through the point -3, 4 and has y-intercept of 1. What is the x-intercept? So first of all, we have to graph it. Graph. Alright, so, well, might be handy. Where's my graphs? There's some graphs. I'll copy this up so I get it a little more precise. Alright, so I'm going to go -3, 4, right there. With a y-intercept of 1 means where it hits this is the x-axis, here's the y-axis. Y-intercept of 1 is right here. Okay, now I ask you to graph that line. So let me draw that line through those 2 points. All you need is 2 points to make a straight line. Okay, and then the next part, it says, what is the x-intercept? Well, the x-intercept, I can see every time it goes to the right one, it goes down 1, right 1, down 1. Right there is the x-intercept, and that x-intercept has, what are its 2 coordinates? It's 1 unit over to the right and 0 units up. So the answer is 1, 0. Freddie, does that answer that question, 42?
Yes, it does. Absolutely.
Okay, do you have another one?
2 more. We have 48 and 50. We can start on 48.
Okay, and if it's close enough to 50, that you kind of feel like your question for 50 is answered, you can tell me. So let's go to 48. Graph the vertical line. X equals -2. Then name its intercept. Okay. So this is, I'm going to just point this out. This is the same as 1x plus 0y equals -2. There's an unwritten 1 as the coefficient in front of an x. And if there was a coefficient of 0 times y, you don't have to write it, because 0 times y is 0, and 0 plus x is x. Right? So this means the same as this, right here. And if I was to make a table of values for it, if I pick -3 for the x, there's no value that I could pick for y that would make this thing true. It would be impossible, because -3 plus 0 times y, but 0 times whatever number you pick is always going to be 0. So this is impossible. You cannot pick. The only thing you can pick for x is -2. But if you pick -2 for x, you can pick anything you want. For y. For instance, you could pick 1. You could pick 4. You could pick any kind of number you want. So, if I graph these, here's a couple of points. -2, 1. -2, 4. And if I connect them together, it's just what they said, it's a vertical line. And number 50 is kind of similar, but it's different enough. I'm going to do number 50. Let's switch color. Graph y equals -3. Oh, and by the way, it said identify the intercept. There is no x-intercept. Well, no y-intercept. This red line never hits the y-axis. And the x-intercept is -2 to the left and 0. The opposite letter is always 0. Okay. Now we're going to graph y equals -3. When I graph y equals -3, again it's the same as 0x plus 1y equals -3. Because if I had something like, now the y has to be -3 every time. If it's something different, it's impossible to get there. If x is like 5, 5 times 0 is 0. 0 plus y is y is -3. Or if this is -1, you're going to get still -3. And when I graph these, the graph of a y equals a number, remember the y's are heights. This is saying, in a way, this is saying that the height of each point is -3. And look, when you have 5, -3, you're down here. Then you have -1, -3, or over here. And then when we connect them together, get this horizontal line. Freddie, does that answer your question on those two?
Yes, it does, actually. It does. Thank you.
You're welcome. Those are kind of exception cases with us. They take a while to get used to.
Yes.
Any other questions?
That's it for me.
Okay, anybody else? All right, it is our break time. So let us start again. At 1:30 p.m. Does anybody need to talk to me individually before I take my break?
Yes, I do.
Yes.
Amalia? Okay.
Hi, Amelia.
Hi. So for the homework, I missed a question in the last two assignments. Just one question, and I only got 8.5 or something. So if I redo the question, do I get full points?
Yes,
or
you can
do I
get
just...
everything back. You can get it up to 100%.
Okay, so how do I do that? Because I did it, but it didn't change my score.
Oh, okay. You did change it and you uploaded it as a new one. All right. Then my grader Nehemiah just hasn't gotten to it yet.
Oh, okay.
Within, he'll make sure that he gets to them eventually. And it shows up in Canvas for him that you have a new submission. So he'll be getting to it. Yep.
That was my question. So do I have to upload like in a paper? Because I was just doing it in the comments.
Oh, you just wrote it into the comment? You know what? He probably won't be alerted to see it in the comment. Yes. And you don't have to upload the whole assignment. Just upload that problem
Just the one question. Okay,
just that
perfect.
One question,
Okay, thank you.
You're welcome. Anybody else need to talk to me? All right.
Quick question. Quick question. How many classes do we have before the exam? The final one?
One more. After today, it is Wednesday's class.
Okay.
And that's it.
Alrighty then. That was quick.
Wasn't it?
It was.
let's start up again. And we are going to section 3.4, graphing and slope. And before we get going, let me check real quick on the groups. Can you all go back to your group number channel and type in hi, and group leader, make sure that spokesman of the day knows who they are. If you're in group 1 or 2, I'm going to have you work with group 3 today. And go ahead and pop into group 3 and say hi. And how many are there in group 3?
There are 4, including myself.
Okay, how many in group 4?
2.
And in group 5?
I think 2.
And I'm here too.
Oh, 3.
3, okay. All right. Let's go back. So, how fast a line rises or falls is the slope of a line. And if it's rising, you're going to get a positive number. If it's falling, you get a negative number. So, the point 2, 1. On day 2, the stock's price is $1 per share. And we're going to be graphing these. Let me make this even bigger. All right. So this is the day number. And this is the price of the stock. On day 2, the stock's price is $1 per share. At that point. 4, 7. On day 4, it's worth $7 per share. It's this point. Okay. The question is the stock rising at a rate of $2 per day? So, go into your group chat, and at my signal, I want you to type in your answer, but don't type it in right away. You need some individual processing time first. So just think about it. When you get your answer, type it into your group chat, but don't hit enter yet. Go ahead and hit enter. Talk about it in your group briefly. All right, group 5. Is it rising at a rate of $2 per day?
I put no, but nobody else answered yet.
Why do you think no?
Because if it's rising at $2 a day, it would be $8 on the 4th day.
Ah, so you'd say if you went over one day, you'd rise up $2. It would be $3 the next day. If you went over a day again, and then we'd go up, it would be like this, right? And that would send you at $5. on the fourth day instead of at $7 on the fourth day. Okay, so it doesn't appear that it's rising up at $2 a day. That's not the rate at which it is rising. So figure out how fast it is rising, how many dollars per day it is rising, and enter that in your group chat. Give you a brief moment. All right, group 4. How many dollars per day is it rising?
I wasn't able to to come up with anything. I think I'd have to like draw a line between the points and then figure out where the points would be.
So your idea is to draw a line between these 2 points. How would that line somehow help you?
I think just because then I'd be able to figure out where they're intersecting. Like I can see now that it's like 3x and 4y. So that might help me figure out what the day is. I mean, what the rise is. Does that make sense?
Yeah. Oh, and you're mentioning the rise. Okay, so how much it rises, well, how much did it rise?
Let's see, it started at 2.1, so 3.
It started at this height, and it finished at this height.
Oh, you mean total? You mean total?
Total rise, yeah.
6.
Okay, so that is the rise. I'm going to draw it straight down from the destination. The rise is the difference in the 2 heights. How much we rose to go from a height of 1 to a height of 7. Now, this horizontal part is what we call the run. Now, the run went from 2 over to 4 over. So we subtract those 2, and those were the x-coordinates of the points. So the run is right there. So how many days did it take for the price to rise $6? It took 2 days for the price to rise $6. What seems natural to do between these 2 numbers? Add them, subtract them, multiply, or divide them?
Divide.
Divide. All right. The stock is rising. Is the stock rising at $2 per day? No. It's rising faster. It actually rises at, and we would divide, we want the dollars and the day, because that's the units we want. How many dollars per day was it rising? And the total rise, we said, was $6. The total run was 2 days. 2 days went by, and it rose in price $6. 6 divided by 2 is 3. $3 per day. That's how fast the stock is rising. Now, how fast a line rises or falls is also the slope of the line. So that's what we're going to call the slope. How fast is it going up? And if it's going down, it would be a negative number. All right. So we're going to look at multiple ways to get the slope. The letter that's normally used for slope is M. And I don't know why, but M is the slope. And since it's how much we're rising, how fast we're rising per day right here, it makes sense that this is, in theory, it's the rise over the run. And when we think of this, how much it rose to how much it ran, we'll look at these 2 points again. When it changes from $1 per day to $7 per day, we say, and let me put a couple spaces in here. We say that this rise is $6. The price rose that much. Ooh, I had a typo here. On day 4, the stock's price is $7 per share. This is 2 days, which we will call the run. 2 days have passed. In those 2 days, it rises $6. It seems like a really natural definition of rise over. Oops, when I did that 2 space thing, I screwed up my things. They're right on top of this, so. That'll just be the way it is. Right. So we get the slope is the rise over the run. And what it was, see these numbers, the 1 and the 7, were the y coordinates. And it's the change in the y coordinates. So we call it the change in y over the change in x. And we use a Greek letter, delta, looks like a little triangle. That means change in y over the change in x. And we also have a formula for this. Now, notice that there's different ways that we could get the slope. We could be looking at the graph and figuring out how much it rose, how much it ran. There's also this algebraic way. How to compute the slope if given 2 points, x1, y1, and x2, y2. All right, now, why do we have a subscript of 1 on these first points because this is the first point. The subscript's just referring to, that's my first point, and so they're subscript of 2 for second point. If that 2 was in the upper position, it means squared. If it's in the lower position as a subscript, it just means it's a different letter than this one. So these are x coordinates, but that's the first x coordinate, and that's the second x coordinate. Okay. How to compute the slope if given 2 points. So we call them x1, y1, x2, y2. If we're using that kind of notation, the change in the y is going to be y2 minus y1, because we just subtracted them. And the change in the x is x2 minus x1. That's what we were doing up here when I did the 7 minus 1. I took the y coordinate here minus the y coordinate. Oh. What? 2? Oh, okay. My graph shifted. And you know what? You can't really delete these lines. Like if I go in here and hit delete, well, sort of I can. There. Alright. That puts them back. Alright. My graph's looking right. Okay. So then, alright, so this is all to do with the slope. So now there's a question. What is the meaning of the slope of a line? And I'm not asking you how to compute it. I'm asking you what it represents, why it's important. So, kind of put this into your own words. And so, go to your group chat and type in your own interpretation. What does it mean, the slope of a line? And I'm going to have you read all the inputs that you get from your group in a minute. So if everybody could enter in something, even if you were putting in, I don't know, go ahead and type that in. But of course, I'm going to encourage you to take a guess. Okay, 30 seconds more. Group 3, what do you got?
We currently have 2 answers. The rate of the given points or the rate of the rise and the run.
All right. What they both have in common is the word rate. And a really common phrase is, for slope, is the rate of change. And the rate of change is, another way to put it is, how much the y changes every time the x increases by 1. Now, let's look at this again in this context, how much the y changes. Look back here. Every time the x increased, I'm going to zoom in real big on that. Every time the x went up by 1, see, we said the slope turned out to be 3. Every time the x went 1 bigger, the y went 3 bigger. Every time you went 1 to the right, that means every day that went by, the price gained $3. And that's very significant. That because when we were actually doing it, we got 6 divided by 2. But what did? We reduced that to 3. We tend to want to put it over 1. And then our minds can interpret real easy. Oh yeah, that's how it's $3 every day is what's happening. It's easier for us to interpret is going up at a rate of $3 per day rather than $6 over 2 days. We change that the run to 1 by reducing it, and then that gives us something that our minds can process real easy. Okay. Now, two points are given. Find the slope using the graph method. So, what I'm going to ask you to do is on your own pencil and paper, plot these 2 points, and then go from the left one to the right one. Go like I did up here. Go horizontally so you're directly underneath the other one, and that's going to be the run. And then go vertically, and that's going to be the rise. So I want you to draw this out. I'll give you a quick minute to draw and then to label on your graph the run and then the rise, and then get the slope as the rise over the run and reduce it if you can. Okay, so I'm going to blow this up and we'll look at it. How do you go from here to here, but you can't go diagonally, you have to go just horizontally and vertically. You run. Now, how much did I run? Well, it looks like I went 1, 2, 3. But that's always the same thing as when you subtract the 2x coordinates. 4 minus 1. And you always go from where you ended up minus where you start. So this is 3. And then we do the rise. Once you're directly underneath it, we rise. It looks like I'm going upwards, so it's going to be positive, and it's 1, 2, 3, 4, 5. It looks like 5. But also, what's true? The run will always be the difference in these two heights, the upper one minus the lower one. And then the slope, we use the letter M for the slope. It's the rise over the run. 5 over 3. So this one doesn't reduce, so we'll just leave it like that. Rise over the run is 5 over 3. Any questions with this? Alright, so let's do another one. No, do the same thing. We're going to get the same answer. But I want you to use, so these 2 points are the same 2 points as over here. Find the slope of the line containing those 2 points, but this time I want you to use the formula. So the formula is that x1, y1, x2, y2, m equals this. Go ahead, plug it in, get the result. Okay, so the y2 is 2, the y1 is negative 3, the x2 is 4, the x1 is 1. We get the same thing, 5 over 3, when we just use the formula. Now, what a lot of people don't realize when they're using this formula, there's a visual component of it. And we're trying to make it really explicit. The negative 3 was the height of the first point. And the positive 2 is the height of the second point. And you find the difference in heights by subtracting those two numbers. And so there's a visual component up here, but you could also do it algebraically without visualizing it at all. And that's really significant here. 2 very different ways to go about and get the same answer for the slope. Any questions here? Okay, here's 2 points. Find the slope using the graph. So the method of graphing, let me give you a minute. Draw this on your own and label the run first and then the rise. And then get the slope. Okay, so negative 3, 2. 3, negative 2. Now, my first question is, if I connect these two with a line, is my slope going to be positive or negative? And the way to answer that is, well, if this was a stock market curve, is your stock gaining money or losing money? Well, it's falling as you move to the right. We always move to the right to interpret a stock market curve. Same thing for slope in general. Okay. So we'd say that this is falling, so it's going to wind up with a negative slope. And the 2 points over here, again, negative 3, 2, and 3, negative 2. And let's do the run first. I'm going from this point to this point. I run till, oops, I went a little too far. Till I'm directly above or below the other point. And then I'm going to figure out how much I ran. Now I could count the little squares, or I can say, oh, remember it's these two x coordinates. There was 3 that I was going to run to get to 0, and then 3 more I was going to run to get to this. Or it's always the rightmost minus the leftmost x coordinate. And that's 6. And then I'm going to fall. So I don't rise but fall, but we're still going to call it the rise. I'm just going to call it a negative number. How much did I fall? Well, let's look again. We had these two heights. So take the upper one, subtract the lower one, and it's 4. So the slope, m, is the rise over the run, 6 over 4, reduce it to 3/2. Alright, so the problems in the textbook are like this. Theoretical, no context. Remember, there can be a context, like stock market. And then, if you'll recall, remember when we were first learning, like adding and subtracting positive and negative numbers? I had you put the context as money. And then later I said, now the context is temperatures. And then we can pick whatever context we want. So the one that I find most useful for slope is to just imagine a stock market curve. Now, stock market curve, you don't get negative values for stock, so y's that go underneath the x-axis might seem a little funny, but basically it's real easy to tell. If it's falling, it should be, but we made this observation.
I have a question.
Yes.
I think that's a -4, not a 4.
I think you are right. Because, look, we made this observation at the very beginning. It's falling, so we should get a negative slope. But we're coming up with a positive slope, so something is wrong. And the rise, we didn't actually, now let's put arrows heads on these. The run was going in this direction, the positive direction, left and right, the positive direction is right. For up and down, the positive direction is up, and we are moving down. So since we are moving down, we're going to come up with a negative number. And this is the one we ended up at. So we shouldn't just take the upper one minus the lower one. If you're doing this, you take the one you end up at minus the height that you started with. And then that's going to give you negative 4. Negative 4. And then this is going to give us negative 3/2 when we reduce it. So that's my slope. There,
Isn't it supposed to be switched? The rise is -4 and the run is 6?
The rise. Oh, you are right. I made another screw up. I'm modeling how to make mistakes here today, which is generally how I usually do homework. So the rise is -4. Usually takes me, when I'm learning something new myself, I make plenty of mistakes. It's part of the process. And then it reduces to this, to -2/3. Thank you, Casey. Good correction. Any questions? Okay. Now find the slope containing the same 2 points using just the formula. So go ahead. So this we call x1, y1, x2, y2, m equals y2 minus y1, x2 minus x1. So the difference in the y coordinates, difference in the x coordinates. Now notice these things are the same things I was doing up here. -2 minus 2, 3 minus -3. This was really, graphically speaking, this was the rise, and this is the run. And I like to put my negative out front when I'm done. All right.
Why is the,
yes.
I just had a question. Why is it -2 minus 2 instead of 2 minus 2 on the second part of that equation?
Okay. So we got to take the y2, which is -2. So that has to go first. So that one with this one. And then the form of this subtraction is this one. And then this x, y1 is +2. Does that answer your question?
Yeah, thanks.
You're welcome. All right. Graphing a line given the slope and the y-intercept. Graph each of these. So now, the common letter that's given for the y-intercept is B. This is the y-coordinate of the y-intercept. M is the common letter for slope. B is the common letter for the y-coordinate of the y-intercept. So, graph the y-intercept first, And then we're going to use the slope to come up with another point. So let me show you what this means. The y-intercept is -2. So I'm going to go right here, make a dot at -2. Now the slope is 3. When it says, it's 3/4. When the top part is 3, that means that's the rise. And that's the run. So from this point, I'm going to do my run first. I'm going to go 4 to the right. Then I'm going to do my rise. 3. Positive 3. And it's going to take me to that point there. So the run is 3. And then I connect these 2 points together. And I've done it. That's the graph of the line with slope 3/4. It's positive slope, so it's going uphill. And you go from left to right. And the y-coordinate of -2 for the y-intercept. Alright, so let me have you practice one of these. The m is 1/2, and the y-intercept is 3. We're running out of time, so I'm only going to give you about 30 seconds. See if you can graph that very quickly. Okay, so the y-intercept is 3. The slope is 1/2, so this is the rise. That's the run. So, my rise is 1. So there we go, rise 1. Oops. I usually do my run first. Run of 2, and then my rise of 1. And then I have my next point, connect them together. There's the line. That's the line of all the solutions of the line that has slope 1/2, y-intercept of 3. Now, by the way, if I'd have gotten my points when I did this slope, let me just point out, if I'd have done the rise first, and then the run, I'd have gotten to the same place. It doesn't matter. But I'm just in the convention, I usually do my run first. Okay, next one. So, the y-intercept is 5, the slope is -3/4. This one's a little tricky, and we've run out of time, so I'm going to have to do this right here. The y-intercept is 5. That's the first thing you do. Put a dot in the y-intercept. Now when the slope is -3/4, you have to put that negative with one number or the other. Doesn't matter which one. So now this is the rise. So I'm going to rise -3. And this is the run. +4. So I get to my second point, and then I connect these 2 points with a line. That's the equation of the line. And negative slope is going downhill from left to right. Alright, so your homework is, hey, we got almost through all the problems. I think there's just one more to go. Homework is 3.4, and in the modules, we've got the final exam on November 9th. It says, and there's a final exam review that's due just before the final. You know, before you take the final, you have to upload your final exam review. And when you do the final exam review, perhaps you've started on it already, really valuable is if you do it like the practice quizzes. So you force yourself to guess. Before you check your answers, you'll get way more out of it than if you just say, oh, I don't remember this, let me look up. Because the answers are on the final exam review. You can go to the bottom of it and find the answers to each problem. But if you just look at it and say, ooh, I forgot how to do this, I'm going to go look at the answer, you won't get very much out of it. If you force yourself, and in fact, what I would do if I was doing it is I would do the whole thing before I looked at any answer. And then I'd go back and look at all the answers and kind of grade the ones, and the ones that I did wrong, then identify and see what I did instead of the right technique and so on. That'll reveal a whole lot, and then you'll be able to change your tendency. So we will stop here.
I have one quick question. It says on Wednesday 7.1 is due.
Does it really?
Yeah, it actually says it.
Where does it say that?
Let me go to my Canvas real quick.
Okay.
Yeah, just hold on.
We're not even doing 7.1.
It literally says it. I don't know why.
Yeah, it says like available until December 2nd or something.
7.1, huh?
7.1 and another 7 after that.
Let me. Alright, I bet it's in the assignments. Let me. Right over here.
Yeah, Randolph is right. It's right there.
Okay. Yep. Alright, so I'm going to unpublish that. And
Try refreshing your screen. Oh, there it goes.
it does it on one, but not on the other.
Try
to refresh it.
you could refresh.
Yeah.
I think maybe because you have it
I can get to
highlighted
it
on the
inside here.
Mhm.
No, it's still not letting me. Oh, it's already somebody's turned in something, so it's not letting me do that.
Oh, no wonder.
So what I'm going to do is I'm going to change it so that it's worth 0 points. So you can just ignore it.
Okay. All right.
I can't unpublish it. All right, thanks for letting me know.
You're welcome.
There's one more, I think, 7.3.
7.3? Okay. Okay. Anything else? Everybody all set?
I think everything is okay.
All right, great. I'll see you all on Wednesday.
All right. Have a good day, sir.
You too.